This is a narrated PowerPoint, which I'm doing on my Macintosh using the Keynote program, similar to PowerPoint. I've prepared a PowerPoint and now I'm narrating it. This is intended both as a demonstration of how to do narrated PowerPoints and as a part of the lesson for the next day, day 10 of the course. HDP 1288. When I look at a table, as I suppose when I do any kind of data analysis, I have to have a purpose. I have to have some reason or perspective, theoretical perspective, or sort of tentative idea of a theoretical perspective for why I'm doing what I'm doing. When I look at a cross-tabulation of two variables, that is the table formed by looking at the number of counts in each cell of each combination of the levels of two variables, that's a cross-tabulation. From a survey, for example, if I take X, a variable which is the age of the respondent, and I have three groups, young, middle, and older, and Y, I have a variable which is an attitude toward education. In this case, my attitude is whether the curriculum today is better or no different or worse than before, or maybe I don't know. When I have such variables in a survey and I've done a cross-tabulation, there's a pretty clear direction to our thinking. I guess it might be apparent. X is an independent variable. It's a variable that describes the sort of pre-existing condition of the respondent, and Y is an attitude that may depend on, or be a dependent variable for our analysis, depends on the age and other factors. These are actually data from a Gallup poll that was given in Ontario many years ago, so I'm not sure that it's substantively very interesting. But there's a pretty clear direction to our thinking. There's a purpose to our analysis. We have the age of the respondents, X, and we have the attitude, their attitude toward education, Y, and we know that X is a prior variable. It precedes chronologically the attitude. It affects the attitude, and we might say in some sense it causes the attitude. There's a directionality to this analysis. The directionality of the thinking of that sort of theoretical perspective determines what kinds of percents we want to do in our cross-tabulation. The idea here is that we want to look at the percent distribution of the attitude. That's the equivalent of a mean and standard deviation in a continuous variable. The percent distribution tells us how many or what percentage of the cases are at each level of the dependent variable of the attitude in this case. And that's what we're interested in. That's what we would be interested in if we were just looking at the variable by itself. And in the case of a cross-tabulation, we're interested in how that percentage distribution varies according to the age of the respondent. That is to say, we think that the age of the respondent is going to produce a distinctive, each age of the respondent is going to produce a distinctive percentage distribution of the dependent variable. In an SPSS cross-tabulation, here I'm giving one, here are the counts, the number of cases for these two variables. It also gives totals in the rows and the columns, and but the central part of the table, the numbers 85, 78, 35, 31, 54, 60, 34, 32, are in fact the cross-tabulation. They're telling us how many cases out of the 409 cases were in each combination of the independent and the dependent variable classifications. But that's not very interesting by itself. It's just counts, and the counts have arbitrary sort of scale because they add up to 409. Doesn't mean a lot. We're interested in two things here. We're interested, first of all, in saying, is there a significant connection between these two variables? And the statistic that we use for that is chi-square. Chi-square asks the question, is the cross-tabulation we were just looking at inconsistent with what might be expected from independent or uncorrelated variables? That's the null hypothesis here. Non-significance here means that sex and attitude are not related. That is to say that the combinations that occur are just what you'd expect on the basis of the frequencies of the two variables separately and sort of random connections between them. So when I look at this cross-tabulation below, I find the actual counts, the ones we just looked at before, and now the expected counts, which are the counts calculated from an assumption of independence. To do that, you just take the totals, multiply them together, and divide by the grand total. In each case, you get an expected count. It's a proportional distribution of the totals. And what we find here is that the numbers are very close, that there's not a lot of difference between what you'd expect and what you got. And the chi-square up above is telling us exactly that. The chi-square here has a value of 0.8. It appears in different versions, but we're really only interested in the top one, the Pearson correlation, the Pearson chi-square. Has 3 degrees of freedom because there are 4 levels in one group and 2 levels in the other group, and 4 minus 1 is 3, and 2 minus 1 is 1, and 3 times 1 is 3. That's how many different degrees of freedom there are in constructing the table, and it's a not significant result, which means that there's no evidence that sex and attitude are related in this sample. The percentage table gives us a better way of describing what we're seeing. The percentage distribution is of the dependent variable attitude, and it's reported separately for each level of the independent variable sex and for the total. Here are the rows, and they're showing about the same distributions for males and for females. It's about 40, about 15 or 16, about 26, 27, 28, about 16 and 15. There's not a lot of difference. The row for male, the row for female are both about equal, and they're both about equal to what the row is for total. This is just another way of saying that there's no effect. When I look at a different variable, in this case I'm looking at the variable age, the age of the respondent, I find that in fact there is a significant interaction. The chi-square here is 31 on 6 degrees of freedom. That's because it's now 3 times 2. 4 minus 1 times 3 minus 1 equals 6. And when we try to interpret the table, the tabulations here, it's a little complicated. What would I say? I would say that middle-aged people think more often that the curriculum has improved, that the percentage of people who say things have worsened is about the same for the 3 age groups. Middle-aged people are very unlikely to say that they don't know, and young people are somewhat unlikely or less likely than old people to say they don't know. Old people are unlikely to say things have not changed. So there's a lot of information here. It's not a simple fact, and we could probably try to interpret that by saying, for example, that maybe whether you think the curriculum is better or worse has to do with what you know about it. Old people may not know much about the new curriculum, and the young people may not know much about the old curriculum. The middle-aged people think they know everything, so that's why they are offering more opinions. And they often think things have improved, so maybe they're reporting some sort of fact. Who knows?